welcome back. Today we have this problem called jump game. Problem number 55. It's one of the most important and one of the most famous problems in Leetcode. The problem goes like this. You are given an integer array called nums. You are initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. Return true if you reach the last index or false otherwise. Okay, so what that means. So let's assume that we have this array. So we return true. Why? Because we can reach at the end in this array. So first we have in the first element it's valued at 2, so we can jump 1 or we can jump 2. So we can jump 1 step, and from this 1 we can jump 3 steps directly at the end, or we can jump 2 steps, and from here we can jump 1 step and another 1 step. So we guarantee that we can reach the end. And otherwise in this array it's false. We cannot reach the end, because as you can see, if you tried all the patterns, you will not be able to reach the last element, which is number 4. So if you tried first to jump 3 times a row, so you'll end at 0. And if you try to reach jump 2 times, you will end at 1. You will jump 1 time, you'll end at 0. You'll try to jump only 1 step, you will have in 2. So you have 2 variation to jump 2 steps directly to 0, or 1 step which will be in 1 and another 1 to 0. So how we will solve that? There are multiple solutions, and in just today we'll try to work with the brute force solution. So it's inefficient solution, it's not that good solution, but however when it comes to data structure and solving problems, you should start with the naive solution. After that you build up and improve the performance. So let's try to think about that. So let's go here and let's add text, and I'll make this one bigger and just make it white. Okay, so how we can reach the end, how we can calculate that in terms of the brute force solution. We basically, this is an efficient solution that as we said before, where we try basically every single jump pattern that takes us from the first position to the last. So for example, we are at number at 2 here. We have 2 ways to jump. We can jump 1 or we can jump 2 steps. We try both. Okay, when we jump 1 step, we are in number 3. We have 3 possible solutions to jump. We can jump 1 step, 2 steps, or 3 steps, and we do all of them. Okay, and for each one, so on and so forth. And we will do this by using like a recursive function. Recursive functions, I guess it will be the best approach for this type of problems. I'm saying again, this approach might give us some sort of limited exceeded. We not guarantee that our approach will even pass. This is how bad the approach will be, but it's a good underground for build up for the next approaches. So let's just try to work at the code. So we said that we will create a recursive function, and this recursive function will try to execute every possible pattern that available. So there is a rule when it comes to building a recursive function, which is to have the base let's call it base situation or the base case. So basically, we don't want a recursive function is the function that calls itself over and over, and we don't want this function to call itself endlessly. Otherwise, the program will crash. So what we should do, we should first find what is the base case, that when we reach this base case, we basically do nothing. We stop executing the function. So first, let's create a function. I will create the function. Let's call it function. I will call it can jump from position, and it will take 2 parameters. One is the position, and the other one is the nums array. Okay. This function we will call it from the main function, which is the can jump, and basically we will return whatever comes from this function. Return. I always run return wrong. We start with the 0 position because we are at the beginning, and after that we call it with all the nums array. Okay, so let's try to find what is the base case. So I would say the base case, it will be until we find the end, or until we cannot loop anymore. So I will say, okay, if the position equals nums dot length minus 1, that means we are at the end, so we return true. Otherwise I will return false. Okay, but I'm just putting some base cases here. Let's try to work on the code. So first, I will create the furthest jump. Like we will try to calculate. We try to determining the furthest position to jump, because based on that we'll try to find all our patterns. So if the furthest jump is 3, we have 3 patterns. 2, we have 2 patterns, etc. So let's just try const. I will say const equals farthest jump, farthest jump, and it will equals math dot min. I will put position plus what we have of nums of position and the actual nums dot length. Nums dot length minus 1. Okay. So let's try to create a for loop. I will say let next position equals the actual position that we are on. I'll create position plus 1, and I will say next position should be less than or equals the farthest jump, and the next position will be plus plus. And here we will say if it's a recursive function, so it's a function that calls itself. Okay, just take it easy, because all the time recursive functions are not that easy to understand. So because it's a recursive function, we try to call it again. So if we call the function again on the next position, if next position and nums, if that will return true, let's return true, and basically that's it. So let's try to describe what's going on here. So first we have a base case. So we checks if the current position the current position is at last index of the array. So we have nums dot length minus 1. If so, we return true, as reaching the end of the array means successfully completed, or means successful completion. After that, we try to determining the furthest possible jump here. This one, we have the farthest possible jump is calculated as the minimum of position plus the nums plus position, because if you have an array here, if you have let's just go back here. If you have an array here, the farthest jump from number 3 will be to number 4. But how we can know that it's number 4? It's that we know it's a 3 plus its index, which is +1, and it will be, I can jump to the index of 4. The index of 4, it will be the element that has number 4. It's just a coincidence. Maybe it can be 5 or something. So here we try to determine, we try to determining the furthest jump that possible. So we said before, the furthest jump is calculated as a minimum of position plus nums, plus the nums of the element of position, and nums the length minus 1. This represents the farthest index that can be reached from current position without going past the end of the array. After that, we try, let's just try to talk a little bit about these 2 lines of code. So we're exploring forward jumps. This is the main thing for this for loops. We try to explore all the patterns that are available. So first, a for a for loop iterates from the position +1, because we try to loop through the next positions to farthest jump. Each iteration represents a possible next jump from the current position. The function recursively calls canJumpPosition, as you can see here, for each next position. If any of these calls returns true, it means there is a sequence of jumps leading to the end of the array from next position, and thus the function return true. After that, we're returning false. So if the loop completes without finding a successful jump sequence, the function returns false, indicates that it's not possible to reach the end from the current position. So let's just try to test this one. It worked. It was accepted in both cases. However, if I submit it here, I will get limited exceeded. Maybe I believe my computer could like explode in my face. But yeah, I got limited exceeded because, as we said before, we did use every single pattern. And as you can see here, because we're using every single pattern, like we're using every single pattern for all of these big numbers. Like we are going through billions and billions of numbers. So because of that, it's not that good as approach. However, it's a great approach as taught. So this implementation of canJump uses a recursive strategy to determine if the end of the array can be reached from the first index. It does so by exploring each possible jump from the current position and checking if any of these leads to a position from which the end of the array can be reached. If such a path is found, the function returns true, otherwise we return false. This approach systematically explores all potential jump paths for each position, and it's not that good to say, and as I say, like 10 times. And in the next, maybe in the next videos or the next courses, we try to talk about maybe better approaches like dynamic programming approaches, and maybe we can work with the greedy algorithm approach, and we talk about what is a greedy approach in the future. So that's it for this video, and I hope you like my solution.